Hello and welcome back to this walk through hypothesis testing. In this class we'll be talking about sides, samples, and errors. No. We're not that kind of side, sample, and errors. No, we're not talking about taking sides in a relationship. We're not talking about sampling different kinds of cakes. And we're not talking about whatever errors this picture might convey to you. We're talking about technical aspects of hypothesis testing. This is going to be a bit of a theoretical, technical class, and so you might say, so what's new, right? Well, a little bit more than usual, but actually fairly simple from the technical point of view, but also very important because the technicalities we'll discuss are technicalities which are often overlooked and often downplayed in research or in the reading and understanding of research papers, and when that is done, unfortunately, you know what happens. The conclusions that we draw from the research may be incorrect. So let's start by reviewing what hypothesis testing is all about. Remember, in hypothesis testing, what do we do? Well, first of all, we identify some kind of research hypothesis. So we want to ask something of the form, is it true that, well, something is going on? Then after that, we identify the null hypothesis. That's the one that says things are equal. They may look like apples and oranges, but after all, they are in fact the same. Then we're going to collect data in some kind of appropriate fashion, which means using some kind of proper sampling technique, and we may also want to summarize those data in some graphs and descriptive statistics and so on. But then on the basis of that, we're going to compute this p-value. And then, of course, on the basis of the p-value, if the p-value is less than the significance level we have chosen, then we say yes, we go with the research hypothesis. Where we thought there was a difference, in fact, it looks like there is one. On the other hand, if the p-value is greater than the significance level, then we don't go with the research hypothesis. So we say we don't have enough evidence to actually support the research hypothesis. So we stay with the null, or at least to say we don't have enough evidence. Alright, so let's look at what technicalities are involved in all of this. First of all, where are we going to look in our research hypothesis? What do I mean by that? Well, there are two majorly different situations. The first one is a situation where the alternative hypothesis may indicate a specific direction of inequality. Let me go back to our good old example of comparing heart rates after doing jumping jacks to heart rates after doing knee bends. One of the things we may want to ask is, well, is it true that the mean heart rate after knee bends is actually less than the mean heart rate for jumping jacks? Or we may be crazy enough to ask if the inequality goes the other way around. Either way, we are identifying a direction. We're saying that one activity actually generates heart rate which is bigger than or less than the other. In this situation, we say that we're doing a one-sided or one-tailed test. One-sided, you can understand why we're siding with one kind of exercise or option rather than the other. Why is it called a one-tailed test? Well, I'm gonna explain that in a minute. On the other hand, we could have an alternative hypothesis that does not really specify any particular direction for the difference. So in this case, we might say, well, is it true that the mean heart rate for following knee bends is actually different from the one following jumping jacks? We don't know which way, but they're going to be different. So in this case, we're going to say that we're doing a two-sided or two-tailed test.